Hello everyone, welcome again in Eng-Man YouTube channel. So we'll have another quick knowledge video, and today's topic is about water flood patterns and sweep efficiency. Okay, so I take this very brief and interesting material from this book. Okay, it's a very good, interesting book about enhanced oil recovery. And we have very interesting tables here. You see on the first column, we have the well pattern and the array or the arrangements of the producers and the injectors with their respective sweep coefficient or sweep efficiency. All right, we have condition here. Okay, so the first condition is, this is the condition where we already reached the water breakthrough from injector to the producer. And then this happens if we have mobility ratio of 1. Meaning if you have mobility ratio greater than 1, which is unfavorable sweep, okay, of course you need to reduce this sweep coefficient or this sweep efficiency or multiply it with another efficiency factor to reduce this number, okay, because mobility ratio greater than 0 is not very good for the sweeping. Okay, the optimum mobility ratio that we expect is 1. It will be better if it is even below 1, okay, meaning the oil will be more mobile than the water. But the optimum one is, of course, unity. All right, so let's check here. The first one, we have 5 spot pattern, 1 producer in the middle of 4 producers at the edges. In this case, we have between 68 to 72%. And then inverted 5 spot pattern, 1 injector and 4 producers at the edges. Okay, we have the same sweep coefficient, 68 to 72%. And then what do we have here? 7 spot pattern. It is even better. 1 producer, but you have 1, 2, 3, 4, 5, 6 injectors at the edges. Now you can get 74 to 82% sweep coefficient. If you invert the pattern to get inverted 7 spot pattern, still you have 74 to 82%. In this case, you have 1 injector at the center and 6 producers at the edges, making 7 spot pattern. Okay, so if you have direct line drive pattern here, direct means you have the row of producer and at the same configuration you have here the injector. Okay, so it's parallel, right? It's a parallel row between the producer and injector. Okay, in this case, you have lower sweep coefficient, 57%. But you need to know, it's very important, this is very important, that the D divided by the A should be 1. Okay, so D here is the distance between producer and injector, whereas A is the distance between one producer to another producer. The most optimum arrangements will be D divided by A equal to 1. Okay, if you have, D divided by A greater than 1, meaning that you have greater distance between the producer row and the injector row, you need to discount this sweep efficiency even lower. Okay, you need to apply it with another efficiency factor to decrease it further. Okay, because it's the performance will be less than this optimum setting, where you can get 57%. And lastly, staggered line drive. You have still parallel, but it's not perfect because now you have, if you have, for example, producer there, you don't have injector at the perpendicular side of the producer. You will create some angle there, but somehow this arrangement, you can get greater sweep efficiency compared to direct line drive. Here you can get at this ideal condition 75%, but still you need to know that the d divided by a should be 1. If you have d divided by a greater than 1, meaning you have greater distance between the producer column or producer row with the injector row, you need to lower down, you need to cut the sweep coefficient farther because now you have less performance, right? This is not as good as compared to if you have d divided by a of unity. All right, and just a short note here. So this is water well, or actually, I think this is wrong. This is typo. This should be oil well, and this should be water injection well. A here is the oil well spacing inline pattern. All right, but you already understand it. Okay, so again, this is brief video. So we have the water flood patterns. We know their arrangements with their respective sweep efficiency or sweep coefficient. It must be areal sweep efficiency or areal sweep coefficient at the condition of water breakthrough already reached and mobility ratio of unity. If you have mobility ratio greater than 1, you need to decrease the sweep coefficient further. You need to discount it more. And also if you have irregular, more towards irregular shape compared to this initial setting, initial arrangement, you need to also multiply this sweep coefficient with another sweep efficiency, right, to reduce it further because the performance will be worse compared to this initial condition. Okay, so I think that's all. I hope you enjoy this brief video. I hope this video is useful. Thank you so much and see you again in the next quick knowledge video. Thank you.